Welcome back, and now it's time to move on to the bulk of these reciprocal functions. We're going to talk about now how to translate them around, how to move the functions around. We're still talking about the same parent function right here, but now we're going to have vertical translations and horizontal translations that work exactly the same way. Whenever you're adding or subtracting from the x, it's going to be a horizontal translation. Anytime you have something added or subtracted to the very end, that's going to be a vertical translation. So let's step through this process. The first thing that I'm going to have you do is identify the asymptotes. All right, so right here, that is moving my x one to the left. So what that means, my vertical asymptote is sitting at x equals -1. Okay, meaning my domain is going to be all real numbers except that x equals -1. So this is where now it starts getting a little bit more interesting. So that's why the first thing we're going to do this time is create those asymptotes. Now what about the horizontal asymptote? Well, here, that -2 is moving it down 2. So just like when we did exponential graphing, just like when we did logarithmic graphing, the shifting is what moves our asymptotes around. And the range, much like the domain, all real numbers except where that asymptote is. Now, if you notice, this time I'm not having you make a huge table for me, okay? Because that just gets to be a lot of work to make a table. So what I'm going to let you do instead is you only need to provide me 2 points, okay? And those 2 points need to be one to the left of the asymptote, one to the right of the asymptote, okay? And I'm talking vertical asymptote. So pick the x, one less than and one greater than the asymptote, and calculate it for me. Calculate that y. So when I plug in x of -2, well, that gives me 1 divided by -1. So -1 minus 2 gives me a y of -3. So I have a point at -2, -3, right there. What about when I plug in 0? Well, 1 over 1 minus 2, so 1 minus 2 gives me a -1. So I have another point at 0, -1. So in this case, I'm allowing you to only find those 2 points because then from there, you can make your branch because you know the general shape of these functions now. So you're just going to use those 2 points to find where the branches are and then just draw it in. Okay, I don't expect you to make a huge table for me. Just find those 2 points. One to the left of the vertical asymptote, one to the right of the vertical asymptote. Now, I realize this is brand new graphing for you, so let's take some good time to do 2 more examples of this graphing. So let's start with our vertical asymptote. Okay, so our vertical asymptote, we're shifting 4 to the right. So our vertical asymptote is going to be at x equals 4. So that's going to be right here. And that means my domain is going to be all real numbers except that x can't be 4. Now, what about my range? Well, this provides me my range. So my horizontal asymptote is up at y equals 6. And what does that mean for the range? Well, it means my range is all real numbers except y can't be that 6. So again, the asymptotes move just like the transformations. Now to find where the branches are, now I'm going to look one value less than the vertical asymptote and one value greater than the vertical asymptote. And I'm going to plug those values in. So 1 over 3 minus 4 plus 6. So that's going to be 1 over negative 1 plus 6. So negative 1 plus 6, that's going to give me a y of 5. So I have a point at 3, 5. Now let's plug the 5 in. So 1 over 5 minus 4 plus 6. So 1 over 1 plus 6. So that gives me 7. So I'm also going to have a point at 5, 7. So again, by plugging in those 2 points, now what you've done is you've discovered where the branches are. Once you know where the branches are, now just fill in the rest. All right. Again, asymptotes, you know your line is just kind of trailing off, approaching it forever. But again, note that you don't need a table for these, okay? I'm letting you get by with just finding a point on each side so you know where the branches are. All right, let's try one more before we move on. So my vertical asymptote here is shifting 1 to the left. So my vertical asymptote is going to be sitting at x equals negative 1. What does that mean for my domain? Well, it means my domain is all real numbers, except I can't use an x of negative 1. That minus 3, that is impacting my horizontal asymptote. It's moving it 3 down. What does that mean for my range? Well, it means my range is all real numbers, except I can't allow y to be negative 3. All right, so now we're going to do the same thing as we've been doing. Instead of making a table, I'm just going to find 2 points, okay? I'm going to find the point 1 to the left of the vertical asymptote, 1 to the right of the vertical asymptote. So let's plug that in. So I get 2 minus 3 or negative 5. So I have a point at negative 2, negative 5. And now let's plug in 0. Oh, I'm sorry. I did that wrong. That would be a positive 2 minus 3. That would be a minus 1. So my first point, negative 2, negative 1, is actually right there. This one, I get the negative 2 minus the 3, which is going to give me the negative 5. So 0, negative 5. And now that I know where my branches are, I just connect them up. Now, how did I know right away that I'd done something wrong there? That's a good skill to have. If you can know when you've done something wrong, obviously it'll help you correct it. Well, I knew because of this negative right here. Okay, because my A is negative, I knew I should be in the opposite branches. So because I was putting myself in what I knew was the wrong branches, I knew to go back and check my work and see what math I had done wrong. So again, very, very good skill to have. Recognize where your answer should be, and so you can make sure that your math matches whatever you believe the answer to be. All right? So, one more skill. So if I give you a graph or I give you a description of the asymptotes, you should be able to tell me what the function is. You should be able to rewrite the function for me. So what I mean by that is, look at this. Both of the following graphs are a translation of the graph y equals 2 over x. What are the equations of the functions? All right, so here, the first thing to notice is they're counting by twos. Okay, so that's a little tricky thing here, is that the graph is counting by twos. All you have to do, they gave you the a value, but now let's see how is my x shifting. Well, it shifted 3 to the left. 3 to the left would look like that, and it shifted 4 up. How am I getting that? Well, I'm looking at the asymptotes. Okay, look to see how the asymptotes shifted. That helps you write out the graph, or write out the equation, I mean. So here again, it tells me A is 2 right away. Now, it shifted to the right 1, because again, if it's counting by twos, halfway is going to be to the right 1, and then down 4. All I'm doing is I'm looking at the asymptotes. Well, if all I'm doing is looking at the asymptotes, that means that I ultimately don't even need the graph. If all I know are my asymptotes, I can still do the same thing. So here, they're giving me A, and if x is shifting to the left 2, that means I need a plus 2, and up 5, that's how I would write the equation. So, do make sure you have that skill as well, being able to write the equation based on the asymptotes and the A value. All right, so as always, thank you so much for joining me for these notes. Please make sure you write your summary for me, and then come back ready to do your practice work.